All right, so here we have an application problem. So it says if the marginal profit in millions of dollars per year is given by p prime of t equals 2t minus t e to the minus t, use an appropriate definite integral to find the total profit to the nearest $1,000,000 earned over the first 5 years of operation. All right, well, I think what I'm going to have is I'm going to go from first 5 years, that's going to be 0 to 5. So that's going to be my part of the integral. And then I'm just going to plug in this piece here. So that's going to be 2t minus t e to the minus t, and then I'll have dt. All right. Well, because of integrals, I know I can split this into 0 to 5 of 2t dt minus integral of 0 to 5 of t e to the minus t dt. And so basically, I have two pieces I can work with. This is part one. This is part two. Part one is easy. I can get that just by direct integration. So I'm just going to have that. So that's going to be 0 to 5 of 2t dt. So that's going to be what? That's going to be a 2t squared over 2 and going from 0 to 5. And so now if I cancel out my 2's, those will go away. And so then basically it's just 5 squared minus 0 squared. And so that's going to give me 25. Simple enough. Now I have to do 2. And so 2 says, and I'm not going to worry about this minus sign right now. I'm just worried about the integral. And then after that, I'll take 25 minus whatever I find out over here. All right, so looking at that one, then I'm going to say, okay, well, if we have 0 to 5 of t e to the minus t dt, well, this is one where I say, well, let u equal t, du equal derivative of that one, dt. And so dv then is equal to what's left over, e to the minus t dt. And I'm going to integrate both sides. So v is equal to what? Well, here I'm going to start letting it say, okay, well, I know that's going to be u, so that's going to be the derivative of that's going to be a minus 1. So I have to divide by or multiply by minus 1. So I divide by minus 1. So then I say that's going to be a minus e to the minus t. Okay, so that's my v. So we're going to start skipping a few steps because we're going to start remembering how to do these. All right, so now I can take my u times v. So u was t times a minus e to the minus t minus, and then I have the integral of, and now I have a minus e to the minus t, and then dt, because that's just dt here. All right, okay, well, I see that I have a minus, a minus. So let's make that a little simpler to start with. Now we have the integral of e to the minus t. Well, e to the minus t I just found right there, so guess what? I'm not going to do that integral again. And so now I get a minus t e to the minus t, and then that's going to be a minus e to the minus t. And then I'm going to take that from 0 to 5. So I've kind of dropped it as I go, but it's still there, as along the way, because this one we're actually going to evaluate. And so I plug in all those numbers. So what do I have? I have a minus 5 e to the minus 5 minus e to the minus 5. And then that's the first piece. And then I have minus, and I plug in 0. So that's going to be 0. And here I'm going to have a minus, so I have 0 minus e to the 0. Okay. So I'm just going to plug that into calculator and figure out what I have here. So I'm going to have a negative 5 e to the negative 5, oops, and then parenthesis, and then minus e to the negative 5, and then minus, and then I have actually a plus, or I can do a minus, but plus e to the 0, which is just going to be a 1. And so I get all that done, and I get, it looks like 0.95957. And so it looks like I'm going to have my overall answer is going to be 25 minus that. So 25 minus 0.95957. And that's going to be equal to, maybe I'll put it to the side because I have to round, I remember. So that's going to be 24.0404 and round it to the nearest million. So it's just going to be about $24 million. Okay, and so that would be my solution to this one. All right, so let's stop with that one and come back for another one.